Welcome back, everybody, to this version that we're having here on the video podcast with Bell and Gossett and the Happy Hour. I have a special guest with me today who is very knowledgeable in the topic that we are talking about today, which is going to be Legionella. This is Khoo. He is the Global Manager for Strategy and Partnerships and M&A within Xylem's Water Infrastructure Group. He is very knowledgeable in water treatment, has some past experience in some disinfection, using UV, membrane, stuff like that technology-wise. So I can't think of a better individual to interview than Kenny. So Kenny, welcome.
Thanks so much. Glad to be here, Kyle.
Awesome. So outside of COVID, which has been a big thing recently, obviously, we're starting to see a lot more things in, come about for water and, issues being reopened, if you will. And one of the things I'm starting to hear about is, a hot topic that's starting to come about more and more is Legionella. Why do you think it's gained some popularity, say, versus other bacteria and really getting that scrutiny?
Yeah, so Legionella, when we kind of look at the various cases in the US, for example, it's actually been rising in the last few years. So I think in 2018, almost 10,000 cases were reported in the US. But this is actually potentially underestimate as well, because these are just reported cases, and the National Academy of Science is actually estimating of over maybe 50 to 70,000 cases actually occur each year.
Oh, wow.
So Legionella infections is happening right now, and that's why it's still in the forefront of people's minds. And the risk with Legionella is about maybe 1 in 10 people that actually get sick from it could actually die from Legionella, especially older populations or immune compromised individuals as well. And it's just the fact that Legionella, even though Legionella is naturally occurring in the environment, it's completely preventable. And I think that's why people are paying attention to it, because it's something that's preventable. Right. We know it's in the environment, but there is something we can do about it.
Yeah, I've heard, I think it's gotten a lot of popularity recently as well, especially in this post-COVID world, if you will. A lot of the things that we're hearing, or at least what I'm hearing and seeing in the world is, all these buildings have been shut down, which kind of leads to stagnant water and, being on water infrastructure. One of the challenges that I've been hearing is that since the water's not being used, there is no residual in the water, or very little, allowing Legionella to propagate, I guess you would say, or grow even within biofilm within a commercial building. So it becomes a little bit interesting. So in your opinion, how do you see the water infrastructure changing to adapt to address Legionella, given its popularity recently, and even more so growing in the future?
Yeah, so you mentioned one of the factors already that people are starting to pay attention on. It's around water age. So again, in our world right now, where water usage within buildings are down, the age within the water within a building can actually promote the growth of Legionella. And the same thing happens in our water network as well. The water that goes from the water treatment plant all the way to building, the water age really does have an impact, because stagnant water allows biofilm to grow, and Legionella can be sheltered within those biofilms. So when it comes to water infrastructure, I think there's going to be a lot of focus around residuals. So, what type of chemical residual or disinfection residuals in the water to prevent the biofilm from forming. There's going to be some attention paid to the nutrients in the water. So we know carbon and iron in the water can help also promote the growth of Legionella, which unfortunately with piping corrosion, you're going to have some iron in the water. And as was previously mentioned, water age is also a critical factor as well. So there's no one silver bullet that would address Legionella as a whole, because Legionella is caused by multiple factors, whether it's the lack of residual, could be infiltration within our water network, stagnant water. So there's a lot of factors that can promote Legionella, and there's, I think, likely in industry, there needs to be a coordinated approach to kind of address Legionella as a whole.
So I'm assuming aging infrastructure is probably not helping at all to it's probably
Yeah,
fostering more of this than anything else,
yeah,
which is going to be a
absolutely, and
challenge.
absolutely, and I think a lot of people realize the infrastructure that's underground right now, they've been installed, maybe in some cities 100 years ago, and
Right.
that type of infrastructure is not perfect. There are leaks and infiltration into the drinking water network, which is why maintaining residual is so important. And fortunately, there are several technologies out there now that are allowing municipalities to detect these leaks ahead of time
Hmm.
and optimize their spending to actually target where the leaks are versus trying to replace large sections of the water network.
Wow. I do know some, and this may blow people's mind, is there are still wooden pipes in areas of the South for water
Mhm.
infrastructure. And if you think about that, how long ago that was, and that just starts to
Mhm.
be a little crazy for sure.
Yeah, absolutely. So,
So, the U.S., we kind of talked a little bit about that from a water infrastructure and some of the challenges. And do you, from a global perspective, do you see other countries applying different actions to address it? Maybe into Europe or
mhm.
even emerging markets, or I mean, I feel
Yeah.
like it's a global kind of, I don't want to call it a pandemic because that's really being used for the COVID more than anything
Mhm.
else, but it's a global challenge, I think, within water being, obviously naturally occurring
Mhm.
with Legionella.
Yeah, it is a global issue because, again, as you mentioned, Legionella is everywhere. It's prevalent in the environment. And I think what's interesting is, Legionella is not a concern when it's in the environment. It only becomes a concern when it gets aerosolized.
Hmm.
Uh, and that's why when you kind of look at uh, the areas where infections occur, they
Sure.
tend to be, near fountains, healthcare facilities, nursing homes, especially through like showers, hot water showers and taps. That's because that's where Legionella can grow within warmer temperatures
Hmm.
and then also get aerosolized, and people can breathe it in, and that's where the problems actually occur. So it's prevalent globally in places like Europe. Some people have been proactive in terms of following building guidelines by either proactively installing technologies that can address Legionella. So for an example, in some European buildings, they will have UV systems either in the cold water loops or the hot water loops to uh, basically disinfect that water and keep that water recirculating through a
Hmm.
UV system to kind of ensure Legionella is removed. And other countries have put out various guidelines, which hopefully people are familiar with in terms of maintaining certain temperatures.
Sure.
So we know Legionella ideally loves 95 to 115 degrees Fahrenheit, but once you get above 130 degrees Fahrenheit, that prevents biofilm from forming. So maintaining certain temperatures in the hot water line, ensuring there's no overlap between the cold water and hot water lines that would facilitate like temperature transfer into
Hmm.
the cold water lines. Because for cold water, once the temperatures are fairly low, it prevents the Legionella from multiplying. And of course, in some of these other countries, including the U.S. as well, certain buildings have installed various type of additional treatment systems,
Like a
uh,
secondary treatment.
like a secondary treatment system, so that they can protect their water supply within the building.
So we mentioned a little bit on the secondary treatment, and there's a couple different options out there for people,
Hmm.
obviously. So I know when reading your bio and your background, right? I mean, UV, I'm assuming is one of them, right?
Hmm.
Being able to kill it. What other kind of other technologies are there to address some of that stuff,
Yeah.
just
So
from a high level?
the most common one that people usually think of when it comes to water disinfection is chlorine. So
Hmm.
various chlorine technologies, whether it's free chlorine, chloramines, or chlorine dioxide. These are certain options that people have implemented in buildings. The downside is obviously now you've turned your building into a water treatment plant essentially, where
Right.
there's maintenance and regulations that need to be followed. Other options are copper silver ionization,
Hmm.
where these ions are put into the water that help actually reduce the biofilm formation within the water system. And then other systems are around either point of entry or point of use type of treatment.
Sure.
So when the point of entry, meaning when the water is entering a building, you could add some kind of disinfection step there. It could be a chemical process, could be a non-chemical process, like for example UV. And for a point of use type of system, so point of use meaning at the tap,
Hmm.
there's certain technologies, again, non-chemical based like UV, or even some filters you can actually apply to filter out Legionella.
Interesting. Yeah, I mean, I haven't, and I've been in the building industry for a little while. It's interesting. Once we start getting more news around Legionella, you start getting owners starting to think about how it affects their
Mm-hmm.
occupancy. I
Mm-hmm.
haven't seen, other than healthcare, and I could be wrong on those point of use ones, they seem to be on a lot of focus on the latter, more on chemical, to your point. I mean,
Mm-hmm.
which is a lot of the municipalities, right? From a water infrastructure perspective. I mean, a lot of the things you just mentioned, the only other one that I can think of that we may not have talked about was like ozone, but a lot of
Mm-hmm.
those are what municipalities are using right now, treating
Yep.
it as it goes too, right? So chemical
Yeah. So
treatment,
so
UV, all that.
there are proven technologies that work, and we know they work against Legionella. And there's the treatment side of things, and also I think people that work in the building services space know about mitigation steps they can take in terms of, again, maintaining certain temperatures in the hot water line, ensuring there's no dead legs in the water lines as well. So
Sure.
there's, again, it's a coordinated strategy that right now can optimize and reduce the risk of Legionella.
Yeah, and on the commercial building side, from my experience, we tend to use what they call the Legionella mitigation plan, at least making sure they
Mm-hmm.
have some sort of plan for their facility to address
Mm-hmm.
some of that stuff. Well, I want to ask this. So, what other government agencies do you think will need to weigh in to, for that larger focus to be placed on addressing this issue? Because obviously it's global, it's not going away. In fact, to your point,
Mm-hmm.
right at the beginning of this, it's starting to increase. I got to think that there's going to be some involvement, and I could
Mm-hmm.
name a few in my head, but I mean, maybe EPA, or is
Mm-hmm.
there a drinking water foundation that should be weighing in on some of this stuff too?
Yeah. So we know, for example, the CDC has been tracking infection rates and kind of publishing their results. And that's one of the reasons why the US EPA is starting to pay a little bit more attention around kind of
Sure.
dealing with Legionella. And it's, it's again due to our aging infrastructure and the fact that we do have either older populations or immune compromised individuals in a very confined space, again, in a building where
Right.
they could be exposed to Legionella. The US EPA does recognize that the aging infrastructure does potentially contribute to the problem of Legionella, because Legionella is coming from the water network itself,
Right.
and finds its way into healthcare facilities, for example. So the EPA is looking kind of two vectors right now in terms of ensuring that minimum residuals are met. So
Hmm.
chlorine residuals in the water to kind of prevent biofilm from forming. So I anticipate we're going to see some more attention in terms of how do we maintain residual in
Right.
the distribution network. It could be a combination of things. It might not actually just be putting more chlorine in the water.
Hmm.
Uh, Chlorine dissipates over time, and there are methods where you can either um, do some water tower mixing, where you can, again, this goes back to the age of the water.
Sure.
If you can imagine a water tower, cold water's coming in, but cold water kind of settles to the bottom, and the warm water settles to the top. So technologies that can mix that water would help kind of reduce water age, and kind of stabilize the chlorine residual. Flushing of the water network as well is kind of being considered as well, again, to reduce the water age and maintain residual. And then it goes back to what we talked about in terms of aging infrastructure. finding those leaks, right? Finding
Right.
those pinhole leaks, finding those areas of intrusion. Fortunately, at least on the Xylem, on the municipal side, we have technologies where we can do sensor-based detection of
Right.
these leaks. So the EPA is definitely paying attention to this because they know due to aging water infrastructure, the risk of Legionella will still be here, and it's very difficult to eliminate the risk of Legionella unless you are proactively actually removing the pathogen from the water network.
It's interesting you say that, because that was one of the things I was just thinking about when you were making that explanation, removing the biofilm, for example. And I can only imagine if I'm a building owner or any commercial facility for that matter, and the spaghetti of pipes that are behind the wall, I know there's companies out there that will actually go and clean all these pipes out for trying to get rid of the biofilm. But if you don't have a plan set in place, I could see that being very difficult to maintain that. Not only that, but it sounds like it'd be very expensive and time consuming. I don't know, even if you took a healthcare facility, can you imagine trying to shut down a healthcare facility to get rid of biofilm, for example, and it's the infrastructure? I mean, I just don't see that being feasible. So it doesn't sound like, to your point, towards the beginning, there's really no silver bullet to take care of Legionella. But there are steps forward from what I'm gathering after our conversation to help mitigate it, if you will.
Yeah, exactly. I think, there are options right now for people to reduce the risk. And that's really kind of what we're trying to kind of educate people on in terms of, there are certain steps that you can take to kind of reduce the risk. And knowing that where the main issues are and focusing on those. So again, based on the reported cases right now, that really the main areas of focus are around healthcare facilities, nursing homes, where individuals are just more susceptible to Legionella. Yeah. So other younger populations are less affected. They tend not to get infected by Legionella versus older populations.
Yeah, it makes sense on why they'd be focused on those two areas for sure. Well, I mean, I can't thank you enough, Kenny, and your background to help us out and at least talk through some of the stuff. It was very eye-opening for sure. I think it was a great conversation the listeners and the viewers are really going to love for sure. So I'm definitely going to have you come back again. We'll have to talk about some more detail in some water treatment, for example. But thank you again for coming on.
Yeah, thank you.
Awesome.